Hello everyone, hi again. Here we are going to explore what the different ways of teaching the diversity of materials in the module Science Diversity and Cycles. So the learning objectives of this lesson is provided with the knowledge that you have learned about materials in the last lesson. You should be able to describe the understanding needed by pupils on materials at Key Stage 1 and Key Stage 2, and thirdly, to state the possible misconception that pupils may have on materials at Key Stage 1 and 2. Okay, so the second part of this addresses what the pupils need to learn, and the final part suggests the effective ways to teach about materials, including how to address some common misconception. Okay, moving on. Um, Younger pupils always find it hard to explain why a particular object is made from a particular material. Indeed, they often find it difficult to separate the object from the property of the material. For example, they may say that the key is hard rather than the metal is hard. Okay, so to break down this knowledge into easily understandable concepts, we can start by naming everyday materials we see around us. For example, wood, stone, metal, glass, card, papers, and so on. We can classify them as natural or made by human. Okay, so wood and stone are naturally occurring, but other materials such as plastics are made by human. So humans take a natural resource and turn it into the materials we see before us. For example, metal was once metal rock ore. Now, can you tell me what made plastic, glass, and paper? Glass was once sand. Plastic was once actually oil, and paper, of course, you know that it is made from wood. So once we have correctly named materials and understood where they have come from, that in, we can turn to their properties. We can look into their properties. Many of the properties will be obvious to pupils. It's either hard, strong, shiny, opaque, and so on. So these properties can be often grouped into opposites as follow. You can put hard versus soft. Let's see, weak versus strong, shiny versus dull, opaque versus transparent, bendy versus rigid, and stretchy versus stiff. So this kind of grouping into opposites allows pupils to sort materials based on their similarity and differences. And this has been proven by research that it's a very powerful evidence-based teaching technique that really help the students to grip with the property of individual materials. Now note that materials have more than one obvious property. For example, wood is hard, which means that you don't have to bang into it. Wood is strong, it can bear a large load, that is why it's used for shelving purposes. It is also rigid, that it doesn't bend that much under weight, and it is opaque, you cannot see right through it. So now can you tell me what are the properties of metals, plastics, and ceramic? Now let us move on to what pupils need to know at Key Stage 1. The statutory requirement for Theme 1, the first theme is on everyday materials, that pupils should be able to identify and name a variety of everyday materials. These are limited to wood, plastic, glass, water, rock, and metal. Nothing so complicated. Secondly is to describe the simple physical properties of materials, and thirdly to compare and group materials based on their physical property. So suggestions for the students to work scientifically in comparing and group materials based on their physical property would be getting them to classify materials as in the opposites adjectives, right? Like I've said earlier, whether it's hard or soft, whether it's stretchy or stiff, whether it's shiny or dull, whether it's rough or smooth, whether it's bendy rigid, waterproof or absorbent, or opaque and transparent. Okay, or pupils could also perform simple tests to explore questions. For example, what is the best material for an umbrella? So, for example, it has to be waterproof, kind of thing. Okay, so you get students to think about it to meet this statutory requirement. For the second theme on the uses of everyday material, we need students to know how to identify and compare the suitability of a variety of everyday materials, including wood, metal, plastic, glass, brick, rock, paper, and cardboard for particular uses. You can get them, as a suggestion would be, you can get them to compare the uses of everyday material in and around the schools with material found in other places, like at home, on their journey to school, on visits, for example, and in story, rhymes, and songs, for example. They can also observe closely in identifying and classifying the use of different materials and record this observation. The second statutory requirement under this theme would be to find out how the shapes of solid objects made from some materials can be changed by squashing, bending, twisting, and stretching. Now you can see that we are applying some kind of force to look at the process of change here. Okay, so it gets more complicated compared to the first theme earlier. Okay, so let's look at the second stage. Now, in key stage 2, the pupils would need to be able to compare and group materials together according to whether they are solid, liquid, or gas. Secondly, to observe that some matter change state when it's heated or cooled. Okay, so we want to look at the changes in the matter here. The third one would be identifying the part played by evaporation and condensation in water cycle and associate the rate of evaporation with the temperature here. And fourth is to use the knowledge to decide how mixtures can be separated. Either you need to filter them, sieve them, or evaporate some kind of liquid to get to the sediment, for example. Okay, so key stage 2 focuses more on the process and how they can elicit that kind of processes through experiment. And key stage 1 is much more simpler, where we look at the uses of everyday materials and understanding the purposes of this material based on their property. Okay. All right, moving on. So it is kind of simple in understanding how to teach materials, and as what I've introduced in this topic. However, material has been proven to be one of the most difficult topic, and it can be misperceived by students in a lot of way. Maybe it's because students encounter with a lot of materials in their daily life since they are young, so they bring in a lot of misconceptions, and we are going to explore one by one what are these common misconceptions. So I'm not typing it up here, but I'm going to briefly tell you what are the common misconceptions. Alright, so the first one, aren't materials just fabric? Here, in everyday speech, we often use the word material to refer to fabric. Okay, for example, you say, "Oh, this material is really hot," for example. And a lot of classroom may have what is called a material box, which is a box full of different fabrics. So this sense of word sort of convey to the pupil that materials are actually fabric. So you might want to check on this understanding before you go on. Secondly, is it the spoon that's hard or the material? In your discussion with the pupils, you may find that they frequently focus on the object itself rather than the material. To the question, which material is hard, they will often reply, the spoon. So ask them then to say what the spoon is made of and stress that it is that material that makes the spoon hard and it's not the spoon itself which is hard. Another approach is to use a materials kit bought from an educational supplier, but I'm afraid that's not available so much in the school now. So you can actually bring a spoon to school and ask them whether it's the spoon which is hard or the material. The third misconception would be the wood is heavy, so it sinks, does it? Now, I used to also have this kind of misconception when I was small. We often think that material that float is, if we compare it to those that sink, they may be surprised that wood can float, as many will expect it to sink. People often think that light things float and heavy things sink. What we are really talking about here is density. Okay, so density can be thought of in terms of how closely particles are packed together in a material. So dense materials have particles packed closely together, whereas less dense materials have their particles packed further apart. Materials that are denser than water sink in water, and those that are less dense than water float in water. So for younger pupils, the concept of density is too difficult, but perhaps an alternative term could be used, and they could think of material as being either heavy for their size or light for their size and sort them accordingly. So wood being light for its size can float, and even a big log can float down a river. Alright. Another famous one would be pupils who have difficulty saying that where a material has come from. Now, when we ask, or research have found that when teacher asks where does this material come from, they would easily say that it's from the supermarket. Okay. So many will give the source of foodstuff as the local supermarket. Try an activity that talks about where does magazine come from. So they might say that it's from paper. So where does paper come from? They might say that it's from the factory. And where does this paper factory got this giant rolls of paper from? They can be from the wood pulp, and then it's from the tree, and then it's from the raw material, which is wood, right? So a visit to a factory of wood, not a wood factory, a paper factory will provide them with good experiential learning. The next one would be it soaks up water, so isn't it waterproof? Many pupils think that absorbent materials such as paper towels, tissue paper, and kitchen rolls are waterproof. Here they are confusing absorbent, which soaks up water, with waterproof, which keeps the water out. So it's a confusion of terms here. It is worth demonstrating the difference to all the students after the investigation above. Okay, so after you have investigated the absorbent property and the waterproof property, then it's worth repeating to them and clarifying all these terms. The next one would be confusing that sand as liquid, because sand can be poured. Now, sand causes problem because it can be poured, and pupils often think that if something can be poured, it must be a liquid. So the reason sand can be poured is that a pile of sand consists of many small grains. A single grain cannot be poured, just like a single brick can't be. Okay, but a heap of sand can be poured, just like a skip load of bricks can be tipped. You may also point out to your students that when liquid are poured, they always have a flat top when allowed to settle, but when grainy soils are poured, they will often make a mound with a pointy top. Okay, so the final one on this slide is thinking that cloth is not a solid because it's soft. Students often think that solids must be hard, as so many solids they encounter in their life are hard, but paper and cloth are solids and are soft. So paper and cloth are very thin, so they can be easily folded. If left alone, they keep the shape that has been given to them, as we would expect a solid to do. So you have to highlight that to your students. We have another 2 slides more to go on the common misconception. Now, another common misconception would be gases don't weigh anything, do they? This comes from the idea that because gases are invisible, they have no weight. A related idea is that because they are invisible, they are not really there. For example, we say a cup drained of liquid is empty. It is empty of liquid, but it would now be full of gas or air. Okay, so to get the pupils to see the difference, try getting them to squeeze a bottle full of air with a lid on. It can only be compressed so much before it pushes back and resists any further force. The second one, air is the only gas there is. People often say air when they mean gas. This is probably because their main experience with gases is the air. The above discussion, where different component gases of the air are distinguished and discussed together with their users, should help. So it's important that you carry out the experiment that tells us the different components, or teach them about the different components of air or gas, so that they will know that air consists of many different gases. The next one would be oxygen and air is the same thing. This may have a reason from younger students being told that we need air to live, and later being told that we need oxygen to live. So they think that oxygen is equal to air. Now, this also tells us as teachers to be careful with what we tell the student. So oxygen is one part of the air. It's about 20% or 1/5 of the composition in the air. So you have to be careful when you say out all these terms. Another one will be air is good and gases are bad. Pupils may have been told to go outside and get some fresh air in their lungs. They may have also been warned of the danger of cooker gas because it is poisonous, and this kind of gas can cause explosions. Aerosol cans also contain poisonous gases, and all these kind of gases like carbon monoxide, for example, a deadly gas given off by car exhaust. So stress that gas has to use with caution, especially flammable or the poisonous one. The next one, air makes things lighter. They might get this misconception from the hot air floats above cold air that they see in, for example, the hot air balloon. Okay, so another related belief is that party balloon inflated by blowing them up with air from our lungs will float away. They won't, as the air in our bodies is of similar temperature to the surrounding. So balloons that do float are filled with what we call helium, a gas that is lighter than air, and let the things float like hot air balloon. And also in the party balloons, if you fill in heliums in them. The next one is on particles are the same size as grains, aren't they? When we talk about particles, students often think about grains, such as sand or powder. We need to get across the idea that particles are much, much, much smaller than that. If you use the idea of particles theory with the students, explain that particles are very small, much too small to see. Okay, so an idea of their size, get the students to look at the rubber at the end of the pencil. Then the distance across the rubber diameter would be about 70 million atoms line up end to end. So they can actually imagine such large number and how really small a particle is. Another common misconception is students thinking that things solidify because they lose water, and this is really common. In reality, when a liquid turns to a solid, the particles in it slow and get closer together and then remain in one place. The confusion arises from things like mud. Mud, right, MUD mud, is a mixture of solid clay and liquid water. As the water evaporates, the mud becomes less sloppy, and eventually, when the water is gone, all that is left is the solid clay particles. Contrast this with wax. When wax is melted, it becomes a liquid, and when cooled, it returns back to being solid. In this case, water plays no part. Okay, so um, the second part is more for the misconception held by students in Key Stage 2, where we look at the processes. Now, pupils frequently mix up the term evaporating or boiling. Now, you have to explain to them that evaporating occurs at pretty much any temperature. It just lower the colder the surroundings are. Talk about puddles evaporating on the playground or etc. Okay. However, boiling only occurs in water around 100 degrees Celsius. Here, bubbles of water vapor form within the water, and the water vapor is released as they burst when they reach the surface. It is not recommended to do boiling water demonstration in the classroom because of the risk of scalding. However, you can look for videos and show them this video in the classroom to make them understand better. So that's a teaching aid for you. Moving on, is it steam or condensation? Adults often refer to windows with water droplets on as steam up. So pupils say on a cold day that steam is coming out from their mouth. What they actually see is cloud of water droplets. Pupils need to know that the process that turns water vapor to water liquid is condensation, and it is nothing to do with steam. Steam, now let me ask you, where does steam come from? That's for you to think. Okay, it disappear. Point number 4, it disappear. This is a common misconception where students often think that when a substance has dissolved, it has disappeared. Certainly, many are invisible, but there are ways to prove that the dissolved solid is still there. For example, pupils should know that salt water tastes salty and sugar water tastes sugary. So as you get them to taste it, for example, you can still feel the tinge of the saltness or the sugary part of the thing that has disappeared. Moving on, sugar melts in water. Pupils often confuse the term melt and dissolve. The correct term is dissolve in this case, so the use of the term here has to be paid attention to. The confusion of melting may be caused when people see foods such as sugar cubes put into hot water and appear to melt like an ice cube would if they put it in hot water. And also filter salt water to get the salt back. This is kind of famous where it's a common misconception, kind of a common. People should observe salt dissolving in water and then use a filter to recover it if they believe it will work. It won't, because dissolved salt is small enough to fit through the holes of the filter. Beware though, if the filter is left to dry, as the water will evaporate, leaving some salt behind on the filter, and the students will believe that filtering works. Okay, so the way to retrieve the salt from the salty water is to actually evaporate the water. Now, you can maybe ask your students if they can work out the quickest way to evaporate the water in order to see salt. So we don't get salt back through filtering, but we get it through evaporating the water. Finally, it's for your assignment in checking your understanding for this. So create one creative lesson plan which incorporates students to work scientifically on the following requirement of Key Stage 2. Now, I have discussed the statutory requirement for Key Stage 2 earlier. However, you have to design a lesson that let your students carry out a simple experimentation in that lesson. And this has to be letting them in using the knowledge to decide how mixtures might be separated through filter, sieve, and evaporation. I'm going to leave you with the option of choosing what kind of mixtures that you want them to separate. Okay, so it's up to your creativity, and the duration should be 50 minutes. Don't forget to include the learning outcomes or the learning targets for your lesson. That's all for this topic. I look forward to all of you to submit your lesson plans to me. Thank you.